Article 300.22b of the National Electrical Code addresses wiring methods in ducts and plenums used for environmental air. Specifically, it outlines which wiring methods are permitted in these spaces. The code states that only wiring methods consisting of type MI cable, type MC cable employing a smooth or corrugated impervious metal sheath without an overall non-metallic covering, electrical metallic tubing, flexible metallic tubing, intermediate metal conduit, or rigid metal conduit without an overall non-metallic covering shall be installed in ducts or plenums specifically fabricated to transport environmental air. There's a provision for flexible metal conduit and liquid-type flexible metal conduit, allowing their use in lengths not exceeding 1.2 meters, which is approximately 4 feet, to connect physically adjustable equipment and devices permitted to be in these ducts and plenum chambers. Now, focusing on the interpretation of this code section regarding the use of flexible metal conduit to extend single-phase branch power, such as 120 volts or 208 volts, from a NEMA box located under a raised floor designed as a plenum to deliver environmental air to a NEMA junction box located above the raised floor. The key aspect is adhering to the length limitation. The code permits this application of flexible metal conduit or liquid-type flexible metal conduit provided that the length of the conduit does not exceed the stipulated 1.2 meters or 4 feet. This allowance is intended to facilitate connections to equipment or devices that require some degree of physical adjustability within the plenum space. To reiterate, the interpretation is correct. As long as a flexible metal conduit does not exceed 1.2 meters or 4 feet in length, it is permissible to use it for extending branch power between the two NEMA boxes, one located within the plenum and the other above the raised floor. It is important to always consult the most recent edition of the NEC and any local amendments to ensure compliance with the latest regulations. Additionally, consider these points for clarity and safe implementation. Firstly, the purpose of the plenum space. A plenum is defined as a compartment or chamber to which one or more air ducts are connected, forming part of the air distribution system. Raised floors in data centers and office buildings often serve as plenums, allowing for the circulation of conditioned air throughout the space. Secondly, the wiring methods permitted in plenums. The NEC restricts the types of wiring methods allowed in plenums to minimize the risk of fire and the spread of smoke and toxic fumes in the event of a fire. The permitted wiring methods, such as type MI cable, type NC cable with a specific metal sheath, and metal conduits, are designed to be fire resistant and produce minimal smoke. Thirdly, the exception for flexible metal conduit and liquid-type flexible metal conduit. The allowance for using flexible metal conduit and liquid-type flexible metal conduit in lengths up to 1.2 meters or 4 feet is a specific exception to the general rule. This exception recognizes the need for flexibility in connecting equipment that may require occasional adjustment or relocation. Fourthly, the importance of length limitation. The 1.2 meter or 4 feet length limitation is critical for maintaining fire safety. Longer lengths of flexible conduit could potentially contribute to the spread of fire and smoke within the plenum. Fifthly, the physically adjustable equipment and devices. The code specifies that the flexible conduit is permitted to connect physically adjustable equipment and devices. This implies that the equipment or devices being connected should have a legitimate need for flexibility, such as adjustable lighting fixtures, sensors, or other components that may require repositioning. Sixthly, the NEMA boxes. The NEMA boxes used in this scenario must be appropriately rated for the environment in which they are installed. NEMA, which stands for National Electrical Manufacturers Association, defines standards for enclosures used in electrical systems. The choice of NEMA box should consider factors such as protection against dust, moisture, and corrosion. Seventhly, the branch power considerations. When extending branch power circuits in a plenum, it is essential to ensure that the conductors are properly sized and protected by overcurrent devices such as circuit breakers or fuses. The ampacity of the conductors must be adequate for the load being served, and the overcurrent protection must be sized appropriately to protect the conductors from overload or short-circuit conditions. Eighthly, the grounding and bonding. Proper grounding and bonding are crucial for electrical safety. The metal conduit and NEMA boxes must be properly grounded to provide a low impedance path for fault currents, which helps to minimize the risk of electrical shock and equipment damage. Ninthly, the local codes and amendments always refer to local codes and amendments that have been enforced by the city, county, or state. These can be more strict based on the area. Tenthly, the qualified personnel electrical work in Plenums should be performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. This helps to ensure that the installation is performed safely and in compliance with all applicable regulations. Now consider the different types of conduits to be used and what the code requires. Firstly, rigid metal conduit. Rigid metal conduit, often abbreviated as RMC, is a heavy-duty, threaded tubing generally made from steel, though aluminum versions exist. It provides excellent mechanical protection for conductors and is suitable for both exposed and concealed locations, including direct burial applications. NEC Article 344 governs the installation and use of RMC. RMC is often used in industrial and commercial settings where wiring needs to be heavily protected from impact, corrosion, or other physical stresses. Secondly, intermediate metal conduit. Intermediate metal conduit, abbreviated as IMC, is a thinner, lighter version of RMC, but it still offers significant mechanical protection. It is also a threaded tubing and can be used in many of the same applications as RMC, often at a lower cost. IMC is covered under NEC Article 342. IMC is commonly used in commercial and industrial construction as a cost-effective alternative to RMC, especially where the most extreme levels of protection are not required. Thirdly, electrical metallic tubing. Electrical metallic tubing, abbreviated as ENT, is a thin-walled, unthreaded tubing commonly made of galvanized steel or aluminum. It is lighter and easier to bend than RMC and IMC, making it a popular choice for many applications. ENT is joined using fittings that clamp onto the tubing. NEC Article 358 governs the installation of ENT. ENT is frequently used in commercial and residential buildings for concealed and exposed wiring. It is not suitable for direct burial unless specifically listed for that purpose. Fourthly, flexible metal conduit. Flexible metal conduit, abbreviated as FMC, is a spiral wound, flexible metal tubing that allows for bending and movement. It is used to protect conductors in locations where flexibility is needed, such as connecting to motors or lighting fixtures that may vibrate or require adjustment. FMC is covered under NEC Article 348. FMC is used in dry locations primarily. It is commonly used for the final connection to equipment where movement or vibration is expected. Fifthly, liquid-tight flexible metal conduit. Liquid-tight flexible metal conduit, abbreviated as LFMC, is similar to FMC but has a waterproof, sunlight-resistant outer jacket. This makes it suitable for wet locations and outdoor applications where flexibility is required. LFMC is covered under NEC Article 350. LFMC is used in locations where flexibility and protection from moisture are needed, such as near air conditioning units, outdoor lighting, and in industrial environments. Sixthly, electrical non-metallic tubing. Electrical non-metallic tubing, abbreviated as ENT, is a flexible, non-metallic tubing that is flame retardant and moisture resistant. It is often used in residential and commercial buildings for concealed wiring in walls, floors, and ceilings. ENT is covered under NEC Article 362. ENT is commonly used in residential construction for running wires through walls and ceilings. It is lightweight and easy to install. Seventhly, rigid non-metallic conduit. Rigid non-metallic conduit, often referred to as PVC conduit, is a rigid plastic tubing that is resistant to corrosion and chemicals. It is commonly used in underground applications and in areas where exposure to corrosive substances is a concern. PVC conduit is covered under NEC Article 352. PVC conduit is widely used for underground electrical systems, such as those for outdoor lighting, irrigation systems, and direct burial applications. Eighthly, surface metal raceways. Surface metal raceways are metal enclosures designed to be mounted on the surface of walls or ceilings to route and protect conductors. They are used in locations where it is not feasible to run wiring inside walls or ceilings. Surface metal raceways are covered under NEC Article 386. Surface metal raceways are used in office buildings, retail stores, and other commercial settings where wiring needs to be added or modified without extensive demolition. Ninthly, surface non-metallic raceways. Surface non-metallic raceways are similar to surface metal raceways but are made of non-metallic materials such as PVC. They are used in similar applications but may be more suitable for environments where corrosion is a concern. Surface non-metallic raceways are covered under NEC Article 388. Surface non-metallic raceways are used in environments where corrosion resistance is important, such as food processing plants, chemical facilities, and coastal areas. Tenthly, cable trays. Cable trays are structural systems used to support insulated conductors and cables. They are commonly used in industrial and commercial facilities to manage large quantities of wiring. Cable trays are covered under NEC Article 392. Cable trays are used in industrial plants, data centers, and other facilities where there are extensive cable runs. They provide an organized and accessible way to manage wiring systems. Now, let's discuss the NEC codes and other information regarding flexible metal conduits, or FMC. Firstly, NEC Article 348. Article 348 of the National Electrical Code, or NEC, specifically covers the requirements for flexible metal conduit, or FMC, and associated fittings. It outlines the acceptable uses, installation methods, and restrictions for FMC to ensure electrical safety and compliance. Secondly, definition: FMC is a raceway of circular cross-section made of helically wound-formed, interlocked metal strip. It provides flexibility and protection for conductors, making it suitable for various applications where rigid conduit is impractical. Thirdly, uses permitted. FMC is permitted for use in dry locations where it is not subject to physical damage, and for branch circuit wiring. It is commonly used for connecting equipment that requires movement or vibration, such as motors, lighting fixtures, and appliances. FMC is also permitted as an equipment grounding conductor under specific conditions outlined in NEC 250.118. Fourthly, use is not permitted. FMC is generally not permitted in wet locations, hoistways, storage battery rooms, or hazardous locations unless specifically listed and marked for those applications. It should also not be used where subject to severe physical damage. Fifthly, size. FMC is available in trade sizes ranging from 1/2 inch to 4 inches. The appropriate size should be selected based on the number and size of conductors being installed. Sixthly, installation. FMC must be securely fastened in place and supported at intervals not exceeding 1/2 feet. When used for equipment grounding, the length of FMC is limited to 6 feet, and fittings must be listed for grounding. Seventhly, fittings. Fittings used with FMC must be specifically designed and listed for use with FMC. These fittings provide a secure connection between the conduit and boxes or equipment, ensuring proper electrical continuity and grounding. Eighthly, grounding. When FMC is used as an equipment grounding conductor, the combined length of FMC and any other flexible metal raceways in the grounding path must not exceed 6 feet. The fittings must also be listed for grounding purposes. Ninthly, bending. FMC can be bent to accommodate changes in direction, but the bending radius must not be less than what is specified in NEC Table 348.24. This ensures that the conductors inside the conduit are not damaged during bending. Tenthly, cutting. FMC can be cut using a conduit cutter or a hacksaw. The cut end should be reamed to remove any sharp edges or burrs that could damage the conductors. 11thly, support. FMC must be supported within 12 inches of boxes, cabinets, and fittings to provide stability and prevent strain on the connections. 12thly, conductors. The conductors installed in FMC must be suitable for the voltage and current requirements of the circuit. The ampacity of the conductors must be derated if the number of conductors exceeds the limit specified in NEC Table 310.15b3a. 13thly, securing and supporting. FMC must be securely fastened to structural elements using appropriate supports such as straps, clamps, or hangers. The support should be spaced according to NEC requirements to prevent sagging or damage to the conduit. 14thly, wet locations. While FMC is generally not permitted in wet locations, liquid-tight flexible metal conduit, or LFMC, is an alternative that can be used in wet or damp environments. LFMC has a waterproof outer jacket that protects the conductors from moisture. 15thly, hazardous locations. In hazardous locations, such as areas with flammable gases or dust, only specially listed and marked FMC and fittings are permitted. These products are designed to contain sparks or explosions and prevent them from igniting the surrounding atmosphere. 16thly, Article 300.22b mentioned in the beginning, regarding environmental air, applies to plenums. 17thly, local amendments. Always check for local amendments. 18thly, use correct NEC box. 19thly, keep to licensed electricians for safety.